We have probably all heard about the gut microbiota, the microorganisms that have lived in our digestive system for thousands of years and are becoming increasingly relevant every day. If you haven't heard it, this is the right video to learn and understand what the gut microbiota is, what its functions are, which common symptoms we may have that could be related to this disorder, and what symptoms and disorders we can address through diet to modify those microorganisms and thereby impact our health. Over time, these microorganisms have evolved alongside us in such a way that today they are essential for the proper functioning of the human body. Our life would not be possible without these microorganisms. There are over 1,000 described species of bacteria in our gut microbiota, and each one participates in a different type of function. Normally, there is a balance among these microorganisms in our gut microbiota. If we disrupt this balance, we allow certain groups to overgrow at the expense of others. And depending on which one it is, it can sometimes lead to the overgrowth of certain microorganisms, such as candida, parasites, proteolytic bacteria. As an initial starting point, we need to understand that there is the gut microbiota, which is beneficial, the beneficial bacteria, and that produces substances that benefit our health, and that gut microbiota, which is harmful if it overgrows, because it produces toxic and pro-inflammatory substances. Both groups are part of our gut microbiota. The problem is not that we shouldn't have these potentially harmful bacteria. The problem is their overgrowth, that there is too much of them. That is the key to making decisions about our diet and maintaining the balance of the gut microbiota ecosystem. The first thing we need to understand is that what we eat modifies our gut microbiota. If we increase our carbohydrate consumption and reduce our intake of proteins and fats, especially healthy fats, we will increase certain bacterial groups in our gut microbiota, which can lead to illness, increased fat accumulation, or difficulties in losing weight. After weight, this happens for a very logical reason. The foods we introduce feed our gut microbiota. If we introduce foods that feed candida or that feed parasites, we will encourage their overgrowth. This can affect us at all levels, including metabolic levels, energy levels, leading us to a pro-inflammatory state, impacting the functioning of our central nervous system, etc., etc. So, we need to understand and clearly grasp which foods will support our gut microbiota, promote those healthy groups, and foster balance, and we need to understand which foods cause an imbalance among these bacterial groups. The main foods that nourish our gut microbiota, harmful and potentially harmful, are actually all the foods in the modern diet today, all refined carbohydrates, gluten, white flours, and all processed foods. These foods promote the overgrowth of candida, parasites, and proteolytic bacteria, which in turn damage the intestinal wall. It is very important to maintain the integrity of the intestinal wall, that layer of mucus with its gut microbiota that protects the intestinal epithelium and prevents a lot of toxic substances from entering the bloodstream. When this intestine is permeable, we have a direct passage of everything in the intestine to the blood, which will first trigger an immune response that may later be related to autoimmune pathology, food sensitivities, etc. Diseases such as Hashimoto's thyroiditis, psoriasis, rheumatoid arthritis. In all these diseases, it is important to always check for an increase in intestinal permeability. If we understand which foods promote the excessive growth of these potential pathogens, we can avoid consuming them, follow an avoidance diet, and recover. With the help of prebiotics and probiotics, the intestinal ecosystem and its balance can be maintained, preventing future diseases. On the other hand, we have a beneficial gut microbiota that we must keep healthy and nourish. The consumption of prebiotic substances, prebiotic foods, and prebiotic fiber is very important. We have the good microbiota, the groups of good microbes. We need to nourish it so that from it we can obtain substances, very beneficial metabolites for our health, which we can call postbiotics. At first, we always associated gut microbiota or microorganisms with something bad, but evidence has shown the contrary. The gut microbiota synthesizes amino acids, vitamins, essential nutrients, and neurotransmitters that affect our mood. All of these substances are provided by our gut microbiota, by that beneficial microbiota. And the entirety of the gut microbiota in balance is beneficial for humans. The best thing we can do to achieve this is to have a great variety in the intestine. To have diversity in the gut, we need to have diversity on the table and vary our diet significantly. Diversity is very important. The lack of microbial diversity is in itself an imbalance of the gut microbiota. The acquisition of different substances, the capacity for resilience, and the ability to adapt are provided to us by a very diverse gut microbiota. Typical symptoms of imbalance include constipation, diarrhea, lack of energy, undigested food in the stool, and all of these indicate that our gut microbiota is not in optimal condition. And we can intervene to stabilize it with prebiotics and probiotics. With prebiotics that feed the bacteria we want to keep in good condition, and probiotics to provide the bacteria we are lacking. Now, once we understand what beneficial microbiota and harmful microbiota are, although it is important to understand that there is not one beneficial and another harmful, but rather it is a matter of balance, we must recognize that they are usually classified into two main functions: fermentation and putrefaction. Broadly speaking, we can divide the gut microbiota into saccharolytic microbiota, the right colon, and putrefactive microbiota, active in the left colon or descending colon. In general, the functions of degradation and fermentation of carbohydrates occur in the right colon, while putrefaction, proteolysis, and the final digestion of proteins take place in the left colon or the descending colon. There is a relevant fact about this division, that if we have discomfort in the right side of the colon, we will have fermentation problems. And if we feel pain in the left side of the intestine, we may have an excess of proteolytic bacteria or putrefactive microorganisms. This is important because with just one sign, we can deduce what might be happening to us. When we eat carbohydrates and do not have a good fermentation gut microbiota, a lot of gas can be produced in that area of the right colon, causing discomfort. These gases do not have a bad smell. And when we have an excess of putrefaction, we produce a lot of gas, but it is very foul smelling. These are clear signs for us to realize what is happening in our intestines. When we have issues with saccharoileitis and the fermentation of carbohydrates, we need to find ways to nourish that fermentation gut microbiota. There are foods that promote this fermentation, which would be fiber, the most well-known being prebiotic fiber, but sometimes when there is a decrease in the gut microbiota capable of fermenting those foods, what we need to do is reduce it, because there is poor tolerance. In the meantime, we will need to work on that gut microbiota to build it up. And thus, in a short time, it will be able to tolerate fiber and gradually increase the gut microbiota responsible for saccharolysis, the breakdown of carbohydrates. So when we have fermentation issues, sometimes we need to eliminate fiber from the diet until we can reduce inflammation, possibly intervening with other substances like a postbiotic, butyrate, or omegas to reduce inflammation, and then we can reintroduce fiber that will feed the bacteria responsible for saccharolysis. Other tools, when we have, for example, an excess of putrefactive microbiota or proteolytic microbiota, include colon cleanses and colon hydrotherapy, which help us eliminate that excess of proteolytic bacteria. This is not as indicated when the problem is fermentation, discomfort, or inflammation in the right colon on the right side, but it is highly indicated when the problem is putrefaction. Colon hydrotherapy is useful in all of this, but it is specifically interesting when there is an increase in putrefaction, and there we are not just going to clean those putrefactive bacteria and not many of their metabolic waste products that are very toxic, such as ammonia or alcohol, or a bunch of substances that are toxic. On the other hand, we must reduce the intake of foods that may increase putrefaction when there is an increase in that putrefaction in the excess of toxins accumulated in the left side of the descending colon, such as meat, animal protein, nuts, alcoholic beverages. Another indication that there is an excess of putrefaction is that when we eat these foods, we produce a lot of gas. It is another clue that our gut microbiota can give us about where things are going wrong. In cases where we have a problem with saccharolysis, a gas formation issue, when we consume fiber, it is sometimes necessary to follow a low FODMAP diet. We need to avoid foods that contain these carbohydrates, such as garlic, onion, fruits, especially fruits like apples, cherries, figs, mangoes, peaches, and vegetables like asparagus, particularly cabbages. You will meet many people who experience a lot of abdominal distension and inflammation when they eat cabbage. Those people have problems of saccharolysis, problems with carbohydrate fermentation. Therefore, they should be avoided until we resolve the underlying situation. And once we have addressed the inflammation, They should be encouraged so that these bacteria that we need to perform this function can grow. In this way, we can conclude that based on our symptoms, we can see which foods we need to consume more of or reduce, depending on whether certain gut microbiota responsible for fermentation or putrefaction is increasing or in deficit. In this context, we can apply various tools in addition to dietary changes. We can use dietary supplements such as probiotics, support liver detoxification, which will help us restore the overall balance of our body, and utilize different prebiotic substances, anti-inflammatory substances, and so on. Microorganisms have many functions that are yet to be discovered. There are increasingly more processes involved with the gut microbiota and more studies linking certain diseases to alterations of the gut microbiota, and we are increasingly finding more terms within the biotics. We have, for example, prebiotics, which serve as food for the bacteria, probiotics, which are the supply of bacteria, postbiotics, which are beneficial substances produced by our gut microbiota and can be provided through supplementation. We even have paraprobiotics, which utilize the bacteria. But when fragmented, they are not alive. This is a lysate of bacteria. We hear about psychobiotics, which refer to those probiotics that have a beneficial effect on the gut-brain axis and our psychological or mental health. One of the most important substances produced by our gut microbiota is short-chain fatty acids, especially butyrate, which is one of the supplements we use a lot when that fiber-fermenting microbiota is low, thus losing its ability to produce sufficient butyrate. We can provide it externally until we manage to have our gut microbiota produce it by itself. It is one of the most interesting molecules that protects the intestinal epithelium, provides energy for that intestinal barrier, is anti-inflammatory, and has a lot of benefits that contribute to a healthy gut microbiota, which has a good production of short-chain fatty acids, offering many health benefits. It is involved in all metabolic processes and in many pathologies with particular importance. On the other hand, bacteria not only produce interesting metabolites for health, but also when we have, for example, an increase in those proteolytic bacteria, we will have a production of very toxic substances when they are present in amounts greater than what the body can eliminate. For example, this gut microbiota produces ammonia, but amino acids are synthesized from ammonia. But if we have an excess of ammonia, we won't know what to do with it, and it is extremely toxic. It affects the intestinal epithelium, and this is one of the main reasons why an increase in proteolytic bacteria is very harmful to health. Besides, it ends up damaging that intestinal barrier and ultimately leads us to a situation that is not local but systemic. If the toxin is not only in the intestine but also crosses that barrier and enters the bloodstream, the problem is no longer local but affects the entire organism. Furthermore, the very production of these endobiotics, these toxic substances, in turn creates an environment conducive to the further growth of pathogens, leading us into an increasingly complicated scenario to resolve. This is becoming increasingly common due to the significant environmental exposure we have in our days, the changes in diet, stress, and all these factors are severely affecting our gut microbiota, leading us to that situation. This situation, apart from those proteolytic bacteria, candida, and the parasites we were discussing, leads us to a very relevant inflammatory scenario in a number of pathologies, resulting in an increase of a specific group of bacteria that are the LPS-carrying gut microbiota. LPS is a lipopolysaccharide, an endotoxin that is found on the surface of certain bacteria and is highly inflammatory. Like with everything, these bacteria are present because when we are little, they are part of the training for our immune system. Everything that is there has its purpose. The problem is that when there is a large amount, it not only signals for training, but is constantly signaling inflammation. LPS cause a lot of inflammation that is local, and when we add that the intestinal barrier has been compromised, we have a perforated or leaky gut, however we want to call it. These LPS then cause a problem of systemic inflammation. They are so pro-inflammatory factors that already signal systemic inflammation without increased permeability, but with increased permeability, the problem is set. This leads us to a scenario called metabolic endotoxemia, which is implicated in a multitude of pathologies, especially in all metabolic disorders, and is altered in all neurodegenerative diseases, as well as in the entire field of neuropsychiatry. It is a molecule, something we need to take into account, very much into account. The increase of these LPS, if maintained over time, will by itself cause an increase in intestinal permeability. There are published studies that demonstrate how an increase in intestinal permeability is associated with an increase in blood-brain barrier permeability. In other words, we not only have inflammatory substances circulating, but they will have open doors to reach the central nervous system. That is why whenever we conduct gut microbiota studies, we look for, it is important to check the increase or decrease in intestinal permeability and the presence of this group of gut microbiota, which are the microbiota that carry EPS. They are generally enterobacteria, but what matters to us is what they have on their surface, which inflames, and leads us to that low-grade chronic inflammation that is behind a multitude of pathologies. The gut microbiota not only provides us with nutrients such as vitamins and amino acids, but it also synthesizes neurotransmitters. So, in these scenarios, in addition to having inflammation, increased permeability, intoxication, and chronic low-grade inflammation, we will have a decrease or alteration in the production of neurotransmitters. In this way, the connection between the gut and the brain is beyond doubt, and it is not just through one pathway, it is through many pathways. Therefore, we always need to check how the gut-brain axis is functioning, whether there is good communication, and it is more accurate to say the gut microbiota gut-brain axis. The gut microbiota primarily communicates with the enteric nervous system, the second brain, the brain of the intestines, which has many neurons, as many as in the spinal cord, and this enteric nervous system relays information to the central nervous system. And this is not one-sided, it is bidirectional, it goes in both directions. There is a continuous conversation between the gut microbiota, the brain in the gut, and the brain in the head. As we have seen, we have microorganisms, and all microorganisms produce substances. They produce metabolites that can be beneficial or harmful. Even harmful microorganisms are not detrimental if they are present in the right amount. Imagine ammonia, which is a fundamental part of amino acid synthesis, but if we have excess ammonia, we run into problems. It's all a matter of balance. It's not about whether a substance is toxic or not, but rather that everything must be in its proper measure. So, in conclusion, we have seen that there are certain signs, certain symptoms that indicate which part of our gut microbiota may be functioning well or may be problematic. And we have already seen that. Depending on which gut microbiota is altered, it is interesting to increase the consumption of prebiotic fiber, to decrease the consumption of red meat and animal protein, to reduce putrefaction. In such cases, colon hydrotherapy and intestinal washes may be beneficial, especially in certain contexts when fiber does not agree with the individual. This means that we need to increase the gut microbiota, but first we have to reduce inflammation in the environment. We must understand that the microbiota as a whole is an organ. It is an organ with an incredible capacity for movement. In other words, if we are exposed to certain toxins, the groups of gut microbiota that can feed on those toxins will increase. And in the process, they will remove them from our intestines. It is a whole, it is an ecosystem like a forest. We must understand the gut microbiota. We cannot separate the microbes. In fact, in our intestine, this great variety of microorganisms lives in multi-species communities. It doesn't live in E. coli in a corner and upstairs in Pterococcus, no. Bacteria, candida, fungi, and viruses, of which we also have many in our gut microbiota. All microorganisms live in multi-species communities. They are highly intelligent communities, like everything in nature, in such a way that the waste of some serves as food for others, and in this manner, the best survival strategy is achieved in communities and teamwork. On the other hand, there are many resources. Diet has a significant impact on the gut microbiota. It is essential that if we have dysbiosis issues or an imbalance in this ecosystem, we make dietary modifications. Afterwards, we have a lot of resources such as prebiotics, probiotics, and various supplements. We must realize that if we broaden the concept of prebiotics and do not only think of fiber, for example, omega fatty acids are an excellent prebiotic that feeds certain bacteria. We can develop each nutrient and assess which groups of microorganisms benefit from that nutrition. So, from now on, we have to keep in mind that what we put on our plate is for more diners than just ourselves, as we need to feed our gut microbiota.